Design of light gauge steel frame for building structures with FrameCAD structure. A tutorial series by engineer Siraj Biswas. Chartered Engineer, Institute of Engineers, India. Gold medalist in engineering stream, University of Mysore. M.Tech in Structural Engineering, IIT, Delhi. Sun Certified Java Programmer, Sun Microsystem, USA.
In today's section, we shall learn the creation of all LGFS wall panel, the panel setting and line commands to be used in FrameCAD software, and then various editing method for the panels. So let us open the FrameCAD software. Let us open the project on which we are working. File, open, sample. That was saved in FrameCAD file. So let us sample building, open. Let us zoom it out. This is our line command. This is our ground floor plan. The first floor plan is also similar to the ground floor plan with some exception at places. So before creating line, we shall create a layer for the line to be created for all the edges. So type layer in the command bar. Click on any of these grid, right click, new layer. Let us name this layer line for line F wall, line for wall. Let us make its color as cyan. We have to change color at both places, cyan. So let us start. Let us first make this line on layer as current layer. So then only we will get this line. Let us check whether we are getting the line. Let us put a line command. Yes, we are getting a cyan line. So we will start with polyline command. Command for it is PL enter. Start with a endpoint for the external wall. This is our external wall. In the around the staircase also we will have external wall. A cyan line can be seen. Let us put up the layer, escape, then LT command, enter. You can see a polyline around the building. So we have certain line along this as well. This line is perpendicular, again this line also perpendicular. We'll extend this line, trim this part, this is trimmed. So let us extend this line to this wall. It is extended. Or we can use the fillet command as well. we have these two parts, the left hand part and right hand part here. So let us join these two parts. So this will be our external command. Let us change the color for our internal command. So color, internal wall color, let us take green color. So make a line, then match. So this will be our internal wall. Now let us go back to our temporary layer. Again LT, the layer is 1, so we have to draw the center lines for this internal wall. So we can take it from here, this wall, drop it here, then for this wall we can take it from here and drop it here. Again there is one more wall, so let us draw a line to have a center point. Let us take a line from the midpoint and drop it here, then extend this line to the other internal wall. Command for it is EX. Let us delete this line. Ctrl Z. We should click it and then delete. Then the white line, double layer line will be there, temporary layer line will be there. Then we have to draw the center line for this also. So we have choose a midpoint, drop a perpendicular, and extend the line EX to the outer one. Enter, then extend. Okay. Now we should delete this line also. So we shall again toggle this layer and put up this temporary layer. So LT, enter. So we can mirror this line, internal wall line. So command for mirror is mirror, MI, enter, and select those lines which are to be mirrored. These are the line. Now select the midpoint at the staircase line. Our ortho is 1 as of now. Enter. So we've got the lines for internal wall. Now we do not have walls at certain places, so we have to use trimming command. So TR, then select those lines and then enter, then select the part to be enter TR command. TR, enter, then enter again, then select the part to be trimmed. At this place we do not have any line. Then again, so we have got the layouts for the wall for placing the LGFS light gauge steel frame wall panels. Now again we have to locate the position of the opening as well. Let us put on the architectural layer again. Now let us make a different color, say red color. COL color command. Take red one. So let us make a line. Okay, it is taking red. So delete it. Line command. L, enter. copy this and paste at various places wherever it's possible. You can paste it here, you can paste it here, paste it here, paste it here, paste it here, here. In a similar manner, you should locate all the openings. Just take line command in the other direction, L enter, draw a line. Now copy this again, see you copy, enter, take a base point. Now keep on placing this and place it at other point. Let us now look at the openings of the internal wall. Copy, CO, L enter. This line is drawn, then copy this line. Take a base point, place it here, here, here. In similar manner, other points as well. Let us look for the opening in vertical direction. So line command again, enter, line command, enter, here, line command, enter, copy it. We have placed almost all the openings location here. So let us put out the temporary layer. See, almost all the part has been, opening location has been marked. Now at some place there is no wall at all, so let us trim that part in the wall line itself so that there is no confusion at all. Here enter, select the line for trimming. So this is our layout for generation of walls. The cyan line shows the external wall and the green line shows the internal walls. Our next command is set command, that is panel setting command. PSET set, enter. So PSET dialog box will appear. So you have to set, take it, set the members here. We will take 89 section 0.956 with 500 MPa, G500, drafting weight is 89, actual weight shall be also 89, maximum length will take 3050, offset distance 0, plaster start is 10. Now here is one point where plaster start needs to be explained. So plaster starts are provided at the junction of wall panel. This is a T junction, you can see. So these are in positive direction. If it's to inside this wall, if the studs come somewhere, this will be negative direction. So usually a plaster studs is provided in positive direction so that board could be fixed to the plaster stud with the help of a screw. The help of the screw here, then screw here. So these are called the plaster stud. So we are going to provide a plaster stud as shown is this figure. So our plaster stud tolerance is 10, plaster stud 2 tolerance is 10. Truss location tolerance, where we will put a truss or a joist over a wall, how a stud should be located below that joist is the tolerance. So it should be either, usually it should be kept as 0, but we can provide up to 40 mm because of lip length of our stud is 89 stud is 40 mm, so we can assume a 45 degree bracket action. So ribbon section is something like that. Over a opening, sometime to strengthen the strength of the member over the opening, you have to provide some kind of capping or L plates. So that is the ribbon type plate. Then next option in the panel setting is load bearing waves to opening. Load LB means load bearing waves to opening. So up to 600 mm will not provide any kind of truss kind of configuration. Non-load bearing waves to opening, wherever there is a non-load bearing wall, we shall not provide any truss kind of wave up to 1200 mm. So integrity option, everything should be true. Reference for every drawing, we need to have a reference. Within every border we need to have a reference point. Panel not level, panel not coded. Every panel has to be coded either load bearing wall or non-load bearing wall or a structural wall. A not bearing wall does not carry gravity load, but it can be used to carry the lateral load. It can be used to provide the bracing. Panel leveling, panels are to be provided. Each panel has to be provided with the length, that is the leveling. Panel length shortage, and if any panel is going to be short, then there will be panel overlap. Panel should not overlap. Maximum panel length should not, the panel size should not exceed maximum panel length. We have set transport limit, yes, it should not exceed the size of transport limit as well. Say a panel should not weight more than 80 kg or something like that. Opening across joint, the wall should not contain any opening. An opening should not come between two shapes of wall panel. Bracing, any strap bracing or K bracing that is provided should not come between two walls. Panel, or wherever the load bearing wall, the panel imposed load should be there. Duplicate level should not be there. So that has to be checked. Show item not detail, yes. Select all. So select on clear all. This need to be false. So almost all the items in integrity check option is true except select all and clear all. Then the panel information. So breast type as of now will take K breast type. Start your single angle. You can make it 45 degree. Or keep it as default 1. Then panel options. Use LB cluster. That means load bearing wall and cluster start has to be provided is true. That is, there is some structural wall, non-structural wall, so that is not used for structural purpose. There also you have to provide cluster start. Overhead and weight limits we have set 80 kg. That is the default in. Maximum height of the stack, that is not much related. It depends on the transportation limit. Brick gap option is not really required. Now we shall we have to draw the exterior wall first. So we know that there is a 8 mm wall, 8 mm board, and then 9 mm HD board. A total of 17 mm. So we can provide it offset of 17 mm for 17 mm here. Let us see why it is. These were our external. So you can see there is a 9 mm thick HD board and 8 mm thick cement board in the wall. So we should keep this offset while drawing the actual width of the LGS wall panel, that is 89 mm. So let us close this. Let us close this PDF file and go back to the FrameCAD file. So we have kept a offset distance of 17 mm. This setting we shall use while drawing the external wall. So save this setting, click on save. Now the command for drawing wall panel is PD. So let us enter PD, enter. So we shall draw panel from point to point. Select the first point, then the last point, and select on the direction in which the wall has to be placed. So you can see it has been offsetted by 17 mm. If you want to measure the distance, DLI, escape, DLI, let us check it measuring the distance. This is 17 mm. So again, we should draw the wall in such a way that we should keep in mind that the opening should not come across two numbers of wall. So let us draw the next panel, PD, enter again. We are drawing the panel for the external wall, offset inside, then this one, offset inside. This one has not been offsetted inside. Let us undo this, Ctrl Z, PD, panel draw, enter. Okay, now it is correct. PD, panel draw, enter. Correct. No, this is not correct. So Ctrl Z to undo this. Again PD, enter. This line seems to be a bit not orthogonal. So let us make this line first orthogonal, then we shall draw this panel. So select this panel, delete it, and we shall trim this part, and here. This has been trimmed. So let us draw a line from here, draw a perpendicular there, here par. So match these properties with this line. Now we shall fillet this line as well. So there is no gap remains. So this is filleted. Now let us see. Okay. So again PD, enter, panel draw this line. So you can see it is offsetted 17 mm inside. Now we are not going to provide. Now if you look at this internal wall, this has an opening. So we do not want this opening to come across two walls. Now if you see the structural drawing, you see the openings are, this is architectural drawing, so outer wall are 230 mm. It has been made with respect to the brick wall setting, but we are making it in light gauge. So the doors are just adjacent to the exterior wall. So we should also keep the door opening similar to this, so that we get maximum space and the architectural intent is also maintained. So this is the reason we are not drawing an external wall directly for this part. We'll split it in two parts. So let us draw the other external wall. PD, enter. inside, okay, then PD and again select inside, then select inside, then select endpoints, inside. This has gone outside, so Ctrl Z, or let us select and delete it. Again PD, enter. Take the direction towards the inside, okay, then we shall take this wall. This is also a external wall. PD, enter, inside. So let us draw this internal wall as well, external wall as well. PD, enter. One part here, then one part here, direction towards inside. One part here, direction towards inside. And one part here, direction towards inside. Now we shall draw the central line, which is internal wall, which is in line with the external wall. So let us go to P set again. Now we do not require to go to P set again here. We are going to use the same command and we'll code the wall as internal wall and external wall. So this wall will also remain inside. Inside. So these two walls are our internal wall. Before we start drawing the other internal wall, we shall fillet all this, fillet or trim or extend all this external wall. So the command is for this is MF, member fillet, MF, enter. So select the panel which we would like to keep a longer length. So we keep this, select on this, and then this one. So this has been made again. To repeat the command, press enter. Select the longer wall, select the shorter wall, again press enter. Select the longer wall, select the shorter wall, again press enter. Select the longer wall and select the shorter wall. In a similar manner, we should trim, fillet or extend all this wall panel. The commands for them is, for extend is ME. For trimming a member, the command is MX. For filleting a member, the command is MF. Now we should always keep on reading the command bar. So for trimming a wall panel, the command is MX. So go to the command bar, MX, enter. Select the member to cut. This is the member we have to cut. Then select member which is continuous. So this is the member which is continuous. Enter. So this has been trimmed. We would like to join some member panel as well. So let us join some panel. The command for this, that is MJ. So go to the command line, MJ, enter. Now select the panel we want to join. This is the panel we want to join. So this has been joined. Then again, this is the panel we would like to join. Again, MJ, enter. Select the panel to be joined to each other. So creation of our external wall panel with few part as internal wall is complete. So with this, the generation of external wall panel is complete. In next section, we shall see how to generate internal wall panels, then how to code these walls as external load bearing wall, internal load bearing wall, and then internal non load bearing walls.